Once upon a time, a school was discussing for a field trip.
Does anybody have any recommendation places for our trip?
Me, miss, I have an idea. What about we go for a hot air balloon trip?
That's good, Peppa. So guys, our trip have been decided.
They need to discover
function.
Now, brace yourselves and let's get started.
It's rewind time.
So, what kind of function do we have here?
Now, let's discuss the function that have been listed.
Firstly, let's discuss polynomial function.
What is polynomial? A polynomial of degree n is a function of the form that have been shown where the a's are real numbers. Although this general formula might look quite complicated, particular examples are much simpler. Thus, you can see each example of polynomial function that have been listed. Let's move on to example of graphs of polynomial function. As you can see, this is a linear function graph. From the graph, f(x equals 2) is a constant function and f(x equals 2x plus 1) is a linear function. Now, we have already know that a quadratic function is a polynomial of degree 2. What is the impact of changing the coefficient of x power of 2? You can see from the smile graph on your left side, as the coefficient of x power of 2 is increased, the graph is stretched vertically. When the coefficient is negative, this means that all of the positive fx values will now become negative. Notice here that all of these graphs have actually been reflected in the x-axis. Lastly, we will discuss about circular function, or mostly known as trigonometric function. In mathematics, the trigonometric functions are real functions which relate an angle of a right-angled triangle to ratios of two side lengths. This set of functions is considered circular, because the functions describe a point on a circle as the function of an angle, which is defined by radians. Radians measure the arc length of a given circle. The six main trigonometric functions are sine, cosine, tangent, secant, cosecant, and cotangent. They are useful for finding heights and etc.
Now, how do we find the inverse function?
The inverse of fx is f-1. Here we can find an inverse by reversing the flow diagram, or we can find an inverse by using algebra by putting y for fx, and solve for x. We may need to restrict the domain for the function to have an inverse. Now, let's move on to inverse polynomial function. As you can see in the video, this is an example of inverse polynomial function. This is where 1 over x plus 1 was inversed and resulted to 1 over x minus 1. Next, is an example of polynomial function which involved cubic function. The inverse of 5x power of 3 resulted to x minus 1 over 5 cube root. Thus leads to this graph of inverse function. The red line representing the function while the black line representing as inverse. Now, let's move on to inverse circular function. Inverse of trigonometric ratios exists. We know that y equal to sin x means y is the value of sine of angle x if we consider domain and codomain both had set are the real numbers. If we restrict the domain of fx equal to sin x, 2, negative pi over 2 to pi over 2, we have made the function 1 to 1. The range is negative 1 to 1. We denote the inverse function as y equal to sin negative 1x. It is read y is the inverse of sin x and means y is the real number angle whose sine value is x. Thus, it resulted to inverse sine graph on your right side. This is another example of comparison between the function and its inverse of graph cos and tan.
Since our job is learning function, let's find out what kind of function in this situation.
Guys, wait a minute, doesn't people's body heat cool down exponentially?
The exponential function is one of the most important functions in mathematics. To form an exponential function, we let the independent variable be the exponent. Thus, it leads to fx equal to e to the power of kx.
This is a graph where a above 1. This graph shown that when x increases fx heads to infinity. As x decreases, fx heads to 0. This is a strictly increasing function. Next is a graph where a between 0 and 1. This graph shown that when x increases fx heads to 0. As x decreases, fx heads to infinity. This is a strictly decreasing function. This is the rule of exponential function. There are 4 rules that you need to know. Next, we will explain about comparison with inverse exponential function. It verifies the graph because the graph of the given exponential functions and its inverse are symmetrical. This is the graph of different value of x and ln x. Lastly, this is the law of logarithm function. There are 5 rules you need to know, which is product, quotient, power, change of base and equality rule. This is an example of an exponential graph of one's body temperature when one's died, since body temperature of dead people cools down exponentially.